I'll be back in 1 sec and we'll start the next lesson. What I need you to do, it'll be helpful for this lesson if you can open the formula book on Moodle, because there are some formulas here and you might as well see where they are in the formula book, but they're kind of difficult to remember. So we can open the semester 2 formula book and look for a section that's called regression or line of best fit or something like this. Okay? So we can just open that now on your phone, the formula book. Guys, in English.
تسوي حطينا بس And it's on page 6, isn't it?
Yeah.
Is that a small S or a big S? It's not super clear, is it? Anyways, page 7 of 16. Okay. Let's continue. Now, part of the difficulty here, guys, come on. Part of the difficulty is the notation isn't super clear, and I think there's differences between small s and big S. I want to keep it similar to what's in the formula book on the top of that page. So, David, what's the first formula on the top of that page?
Y minus y.
Bar? Yeah, so this is the first formula, is it?
Yes.
Equals sxy over sx squared x minus b x minus x bar. Okay. Put that down now. And then what's the second formula? Is it this one, sxy equals?
Yeah.
And what do they have on the top? Sum. Oh, thank you. Sum xy over n minus xy. And then you have Sx equals square root sum xi squared over n minus average squared. And then the last one you have is the same thing but just with y. They're the four formulas. yi squared over n minus y average squared, like that. Yeah? Yes? Do you need to add? Well, it's in the formula book that you have for the exam, so. Now, I like to make it, guys, what's wrong? I like to make a little bit of a convenient distinction here. I can't quite tell from the formula book, but I imagine all these S's are small S's. Now, maybe you might strongly disagree if you look at the formula book. I don't know.
Yeah, they are capital S's.
You think they're capitals?
Yeah.
You strongly feel that?
Yeah, because X is small, so.
Yeah, but okay. I don't know. It really looks like a small S to me. Anyways, no matter. I'm saying there's small S's in the formula book. Whether they are or not is not important. I'm just saying they're small S's. Because what I would like to do, just to make it a little bit convenient, is to have a different meaning for big S. So if I have big S x, I like to write that as shorthand for the sum of all the x's. Yes. Instead of having to write sigma xi. And you can probably guess what I mean by big SY.
Usually sum of the
Sum of
y.
the y's. And then SXY like this.
Both
Sum of what?
X and y.
Sum of x times y. Okay? It's just convenient for me because it means I can say that this is equal to, yeah, actually, so this is the sum of what? Y squared. Or in other words, the sum of y times
Y.
y. Yeah. So you could write this as SYY over n minus y average squared. Yeah. Or for example, how do you get the average? How do you get the average? Sum of y over n. And we have in the formula, this is squared. You don't have to use this notation. I just find it convenient. I just find it convenient to write Sx to mean add up all the x's. Sy to mean add up all the y's. And Sxy to mean add up all x times y. You know? But I don't want to confuse you. So that's why I'm saying these ones here are big S's and the ones in the formula book can be small S's. Okay? It's convenient to use this.
Okay.
This is the formula book. And I'm saying these S's in the formula book, I'm calling them small S's. And these S's here, I'm calling them big. And the reason I'm doing that is I don't want you to mix up the two. Okay? This and this. What does this one mean? Add up all the x's. Yeah. Capital S. Add up all the x's. And this one here is that.
So now the formula is the same as the down?
Yeah, the small sx is this formula in the book.
Okay.
Now, there is another reason I'm doing this. If you look at this formula, it should remind you of another formula you've done recently. What? Yeah. Isn't this the formula for standard deviation?
Oh,
Yeah. Do you remember we said we had sigma squared equals the average of x squared, first you square then you average, minus average first and then square. So if you take a square root, you get this formula, don't you?
Yeah.
And I told you there's another letter that means standard deviation. What letter did I say? I said it was S. Okay? Or I sometimes write SD. So this is why I'm making a point here. I'd like these s's in the formula books to be small s's for two reasons. Number one, because I want to use s here to mean sum, big S. And number two, so that it matches what you did in an earlier lesson where I told you you can use small s for standard deviation as well. So there is a reason I'm making this point here. Now, this lesson is really a calculation lesson. What we're going to learn is how to calculate exactly the line of best fit and not rely on our judgment. Okay? So, what I'll do is I'll use the data from the last lesson as an example. And we'll see how good our line was compared to the true one. Yeah?
So I think we are getting the start and the end point, something like that.
We'll see. We'll see. Can someone give me the data we had in the example in the last class?
0.
So 0, 20, 40, 60. And then the y's?
40, 55,
60. And what was the answer we got? Y equals 0.42. Yeah, so in this case, x plus 38. Now, the answer I'm going to get in a minute will be mathematically the most accurate line of best fit. Okay? So, just to practice, we'll just calculate a couple of simple things first. So, the first thing I'll calculate is big S. Actually, I'm just going to delete that line for a moment. Okay. I'll write it here. Big S x. So this one here, what am I meaning? Sum of the x, which in this case is 120. Good. Okay, B. Let's get big S y. So what was that? 205, wasn't it? Wasn't it? Okay.
So just this one?
That's it for this part. C. Let's get big S xy. Alright, so now it might be helpful to make a new column here, right? xy. So that would be 0, 1000, isn't it? No, 1000, yeah? The next one? This one? Yeah?
Why you didn't multiply 122?
Hang on a second. What is it? Oh yeah, 7,800. Yeah. No? What is it? Add these up? 6,800. Okay. What's wrong, Hazza?
No, because xy, you should like 120 times 205.
Should you? Should you?
Yeah.
No.
Because
No.
why?
Why? Let me show you. Here's x, here's y. X will say is 1, 2, 3, and y will say is 1, 2, 3.
Okay.
Now let me add these up. What do I get?
5,
3. Try again.
6,
6. And add these up.
6,
6. And if I multiply them, I get 36. Okay. Now what's 1 times 1?
1,
1. 2 times 2?
4,
4. 3 times 3?
9.
9. If you add them up, is it the same?
No.
No.
What?
So your shortcut doesn't work. You have to individually do it.
How it should work?
No, it shouldn't work. I know it feels like it should work, but it doesn't. It doesn't.
If I dance it the same.
It's not. It's not.
It's not the same.
It's not. No, trust me, it's not. What is this like? This is a little bit like, you remember when we first got the average, first we squared and then we got the average.
Yeah.
And then first we got the average and then we squared. Were those the same numbers? No. Similar things happen in here. You still don't believe me. Trust me. Similar things happen in here. If you multiply and add, you won't get the same answer as adding and then multiplying. Right? So when I write SXY, which is it first? Multiply then add, or add then multiply? What's the order here?
Then what you got?
No. Multiply individually and then add. Okay? Right. Continuing now. So the next one we'll do, let's calculate next. I think we have this from the last lesson. X average. What did we say that was? That was 30, wasn't it? Yeah. And E, let's calculate Y average. What did we say that was? It was 51.25, wasn't it? Okay. Now, what I want us to do now, another practice one, calculate XY's average. Now, we have them here, don't we? So add these together and divide by 4. What do we get? Yeah. What is it? 30? Exact?
Yeah.
Yeah.
So now if we multiply 30 by 51.25, we're not.
Yeah, will 30 times 51 give me that?
No.
No! This is too much for you to handle. This is too much truth in one lesson, I think. Okay, continue. Can I scroll down? Or I'll zoom out a bit. Right. I just need to do, let's see. Yeah. Now, let's calculate small sx. So, according to the formula book, guys, come on, listen. Are we okay with these 6 here? Yeah? All right, now, to the formula book. So, what is small sx equal to? Square root. So, what's the first one? Oh, I missed one here, didn't I? I'm not quite ready yet, because I haven't done xx, have I? I've done x, y, xy, now to do xx. And then, yes, then yy. So what's xx? What's that one? You have to add up all the x squared, isn't it? Yeah, so what's that? 0, 400, 1600, and 36, 0. Yeah, so those 4 added together, what do we get? $5,600. And Haza, do you notice that this is not what? It's not 120 times 120, is it? Yeah, very good. Okay. Right. Now, Right, now let's get our small sx. So, according to the formula book, you should still have open, it's square root, and then what's the first one here? Sum xx, was it? Yeah.
This is 5 or s? Sx or 5x?
Which one? Sx.
The capital or the small?
Small.
Oh yeah.
Yeah.
So is this
No, guys. No, Kirill, that's fine. Look, I'll explain it here. In the formula, you had this, isn't it?
Yeah.
Which is the same as x times x, because it's square.
Yeah.
Which is the same as adding up xx. Yeah. So, in the formula, what number's on the top here?
5, 6,
5,
0.
yeah,
And what's here?
4.
4,
And then minus, what's the next number?
Average x squared.
Yeah, so what's that?
T squared.
And what's that equal to?
900?
Is the total with the square root 900? which is
22.66.
22.36.
22.66.
like that.
Yeah.
Yep.
Yeah. Okay, there we go. You get it?
No.
Yeah.
Just the-
Yeah. Say again. What? Yeah. Well, the formula in the formula book. What was here in the formula book? Average x squared, which we worked out to be 30. Yeah. Now the next is small sy. Is it? Sorry, xy. That's in the formula book, isn't it?
XY.
Yeah. xy.
Okay.
What's the formula book say?
It's,
Sum of XY,
Yeah. What's that?
which is 6,800
Over 4
minus
minus
X average times
x
Y
average times y average. Okay, so what's that now?
Ah, okay.
Yeah. What's this?
confused. It's not okay.
What's this? What is it? 12.5?
162.5. Square root.
I don't think there's a square root in the formula.
Yeah, there is 162.5.
162.5.
1, 6.
2.5.
Are we sure?
Yes.
Okay. Now that we've done all that, we're finally in the position to calculate the line of best fit. So I think there's one more formula in your formula book that says y minus y average. Do you see that?
Yeah.
That's the line of best fit. Let's fill it in. So y minus, what was y average? Guys, come on, focus, crew. Y minus y average, what's y average? 51.25 equals, and now I think we have a fraction, yeah?
Yes.
What's on the top?
SXY.
Which we've just worked out. 162.5. And then on the bottom,
Wait, what's
look at the formula. That's your calculator. What's on the bottom of the formula? Small s, sx squared. Yeah, which we worked out to be 22.36, so that gets now squared. Yeah? And then next is x minus,
average X?
and what do we say the average was? What,
51.
the average of x, I thought was like 30.
Yeah.
Yeah?
Yeah.
Now, let's clean this up a little bit. So, using your calculator carefully, can you tell me what this number is? 0.325.
Yeah.
Okay. Now, what I want you to do is to multiply that by 30. 9.75, is it? And then I want you just to add 51.25 to it. 61? No. 51.25 minus 9.75. Plus 40.5. Now, the equation we got when we estimated it was what? Y equals 0.442, was it? X plus 38. Now you can see that, okay, unsurprisingly, we weren't exactly right because we were estimating it, but it's not like we were a million miles away, were we? We have underestimated the C. We thought it was 38, but the formula says it's 41.5. And what else did we do? We overestimated the coefficient here, the slope. We said it's 0.442, whereas here it is 0.325. Now, what is happening mathematically here? This formula here will be the best formula, because remember we were talking earlier about the residuals. Yeah. This one here is the formula that will give you the smallest possible residuals.
Is it possible to have a residual 0?
I mean, like in this example or in any example?
Any example?
It is. The only time that would happen is if all the points were on the line. Yeah. But anyways, the formulas that we used are designed so that the line that we find will be the best line, making the total residuals not zero, but a minimum. Yeah.
So now if you put these like,
You get the predictions.
it's gonna be like exact line.
No, it'll just have the least error.
Oh, okay.
So if do you remember earlier when we calculated the y hat? Yeah? If we were to calculate the 4 values here, we will discover these 4 values are the closest we can get to the original values, and we can't do any better than that. So this is the best line using these formulas.
Okay.
And this is good to see that our guess wasn't really that bad. I mean, if I used graph paper, I probably would have it more accurate, but it's not that bad. Right? Now, I know there's a lot of calculations here, but there's some good things to note. In the exam, you see these big S's I had at the start?
Yeah.
They usually give those, and in fact sometimes they usually give the averages as well. So normally you're actually starting from here.
Yeah.
And where did we get the formulas for this? From the formula book. So really the only thing you're doing in this lesson is using the formulas in the formula book with the numbers provided. Okay?
But what are
Huh?
Do you get 4?
Where do I get 4?
Yeah.
N is 4.
Uh-huh.
Yeah. Yeah.
Do you know?
Well, I go 1,
Yeah,
and then I go 2, 3, and 4.
Is there a 5?
so
Yeah, sometimes there might be a 5 after 4. Yeah.
So
Yeah.
what about the formulas that are in the beginning? Those like.
No, they're not in the book, but you don't really need them. So guys, I showed you the big S notation because I don't like having to write the sigma x and the sigma x squared. But it's not necessary. It's not necessary to use that notation, okay? Because if you look at the formula book, for example, they make it very clear in the formula book. I think they say small s x equals, what was it, square root sum x I squared, was it? Over n minus.
X
It just means like data 1, data 2, data 3, data 4. What's the next part?
average x.
Do they write it like this?
Yeah. Square.
Squared. Right? And then in the question they would often say, note, sum xi squared equals whatever. Do you see?
No.
See? They would say that in the question.
So what like?
So that's good. Because you take that number and just put it in there.
Yes.
Ah.
Let's
Yeah.
work.
Less work.
Oh,
Less
okay,
work.
Okay, yeah.
Okay, good. Good. Right. You desperately need to practice one, I think.
Yeah.
So if you look at number 2, do you see that, for example, I tell you in the question, big SX. What am I telling you here? If you add up all the x's, you get what?
The number.
0.26 then.
Yeah.
Yeah? Guys,
How
Come on.
the SX?
yeah, in question 2.
Yeah, SX.
Yeah. I say it's 0.26 in the question, don't I?
Yeah.
So what am I saying? That you add up all the x's, you get 0.26. And what's the next number mean?
You add all the y's.
And you get?
63.
And what's SXX meaning?
X squared.
Add up all the x squared, and you get 19. And SXY?
X times y and sum of it.
No, not x squared y.
Sum of
Yeah, x times y, sum of all those numbers. Yeah? Now, in the exam, they would write it like this, though, just so you know. They'd make it even clearer. They would say sum x equals 0.26. Sum y equals 63.27. Sum x squared equals 19.5. Isn't it? 19.5 roughly. Yeah? Yeah, yeah? Okay. Okay, fine. 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 Right. What I want you to do now before you finish is question 3, and then at home you should practice with question 4. 3 and 4.